Hi everyone, I am Sanya Kuler and this is Cute Little Yankee, and in this video I'm going to explain how you go from a joint probability distribution table for three random variables, how you can go from that into three circles into a Venn diagram. So how do you go from a joint probability distribution to a Venn diagram? So please stay tight with Yangshi and me in this video. That is, in this video we will be talking about how to go from the joint probability distribution for three random variables A, B, and C here to the Venn diagram representation. So here, for instance, we see the probability A is false, B is false, and C is true is 0. The probability A is false, B is true, and C is true is 0.3, 30%. The probability that A is true, B is false, and C is true is 20%. The probability that A is true, B is true, and C is true is 20% as well. The probability A is false, B is false, and C is false, so all three are false, is 30%. The probability A is false, B is true, and C is false is 0. And A is true, B is false, and C is false is 0. It doesn't happen. And A is true, B is true, and C is false is 0 as well, so it doesn't happen at all either. So how do we go from this joint probability distribution table here to the Venn diagram representation? So again, these probabilities here, they need to sum up to 1, which they do because, 0.3, this is 0.3 here, 0.5, 0.7, 1, 0, 0, 1. So it's all 1. So this adds up to 1, which it does, which is great. All the 8 possible outcomes here in this distribution. So 2 for A, 2 for B, 2 for C. So it's 2 times 2 times 2 because of the outcomes for each of them. 8 total outcomes, and that's indeed, these are 8 total outcomes as well, like the tautology values. So we're going to see how we go from this representation just to this, step by step, like how do you visually represent it using a Venn diagram. So we know that like how we typically do a Venn diagram for two variables, like A and B, for instance, and whatever is in common, this is A and B, which is what I've shared, and I'm shading. This is A. Oh gosh. This is A and B, for instance. And we're going to just see how we can, similarly, when we add in another variable to the loop, how we can figure out what those other terms are. Like how can we represent each of these things as here? So this is the corresponding probability, joint probability distribution, and the respective Venn diagram. So let's see how we label this guy. Starting off with A is false, B is false, and C is true, that is 0. So what this is saying is that just basically C is true and A and B are false. So only C. So that's what we are wanting. We are only wanting only C. That's what we're looking for. So A cannot happen and B cannot happen, but C is true. So we only shade this region here where C is true. So this part does not include, this yellow shaded part lies outside of the orange circle. Whatever's in the orange circle belongs to, if it falls in the orange circle, then A is true. If it falls in the green circle, then B is true. And if it falls within the purple circle, then C is true. But instead, we just want the part of C that does not include any of A or B. So that's why we have this here, because B and A are false. So that's why we shade this part here. That's what it corresponds to. Only C, because of this part here. Okay, great. We got 1 out of 8 done. So now we're on to the next one. A is false, B is true, and C is true. So A cannot happen, but we do need for B and C. This is just saying only B and C. So that's sort of what we're looking at, only B and C. So we see, okay, this is B's, this part here is B. And then for C, we're trying to find where is the overlap between these two variables. So we see that, okay, pun intended C, so we just see that this is this yellow part here that I've shaded. This is the part that does not include A in it. If we included A as well, then it would have included this part here. This semicircle kind of thingy like this. But since it's not, then we're sort of just including this 0.3. This is just the part of B and C that does not include A. And so you'll also notice that some of these probabilities have 0. So in reality, the Venn diagram bubble would not exist there, because that's not possible, but we're showing it for illustration purposes. So hopefully you would probably expect to have some non-zero entries here. But this is sort of like a continuation of an example that I was giving using a Bayesian network from earlier, and I've put the video up there as well for you guys to watch. So I just wanted to continue with the same joint probability distribution that you get from there, so that you can follow along from that. But hopefully, like, some of these would also be non-zero, but again, they would all have to add up to 1. So again, this part here that are shaded in yellow just represents only B and C, the intersection of those two. The and is given by this as well, which I like to think of as this as being like and. So that's what this is represented, the and between B and C only, and it does not include A. If it did include A, it would have been this whole thing here, but it's not, so it's just this yellow part. Now, similarly, we're just going to look at A is true and C is true, but B is false. So that's just going to be, equal to only A and is saying C. So this is just the part of A, this orange part here, overlapping with this purple part, but it cannot include this green part inside, which is B. So we cannot include this, even though that's what A and C also combined include this. Since B is false, we cannot include this part, so we will not include this because B is false. So B is false leads to that being cut out. So instead, we just use this part here, which is in yellow. This is the overlap between A and C, between the orange of A and the purple of C. This yellow is the overlap between A and C. So that represents a 20% probability here. And now, this one is a great one. This is the probability of all 3 random variables being true. So A is true. We look at the orange part here. So basically, we're like, okay, let's look at where the orange part meets orange. This is within the orange border. That's because A is true. Then because B is true, we look here. And similarly, because C is true, we also look, okay, well, what part falls within? I'm not really good at drawing, as you can see, but we see that where do all these lines happen to me? What is the intersection of all 3 of these circles? Well, it happens to be just this part in the middle. This part is within the orange part, which is A. This yellow part is within this green part here, which is B. And this yellow part is within this purple border, which is C. So this is the 20% that where A is true, B is true, and C is true. It corresponds to this part over here. And now we're going to see, okay, well, A is false, B is false, and C is false. So none of those are true. So all that is that is just going to be the region outside of all three circles, because none of those outcomes is happening then. And this is the 30%. This 30% represents where A is not happening, and B is not happening, and C is not happening. So it's the exact opposite of the previous in a way, but it's not, but you might think it is, but it's not quite the opposite, because that was and true. So this is just saying that none of them are true. And that one was like very restrictive, where you find the overlap of all three in this example here, which is 20%. Now this example is saying that all three of them, none of them are happening, so they're all false. And that's exactly outside of these circles. So that's what this represents. This 30% represents everything outside of the Venn diagram, Venn diagram part, but still part of the sample space of outcomes. So yeah, this 30% represents all the shaded outside of the ABC. And next, okay, so A is false, B is true, and C is false. So how you interpret this is just simply equal to only B. So B is true, and the rest are false. So we just have to look at the part of B that is true, where it does not intersect with A because A is false, and it does not intersect with C because C is false. So because C is false, we cut that part out. Because A is false, we cut out that part. So basically, just to think of it again, this part of only B just is this part here, the part of B that is true, where A is not true and C is not true. So this part here, where A is false, B is true, C is false, is 0. Only B is represented by this. And next, similarly, where A is true, B is false, and C is false, that just means that only A is true. Only A, please. Get your A game on, guys. So only A. So that means that we're just looking for where A is true and B could be false. And B is false and C is false. So because B is false, we do not include this or this. And because C is false, we don't include this and this either. So we're just focused on this part here, because it's only A, where A is true but B is false and C is false. So we're almost there. We're just getting on to the last one, where A is true, B is true, and so A is true and B is true, but C is false. So all that's saying is that instead of, so A and B are true here, but because C is false, we do not, because of this part here, we do not consider this part of the overlap between A and B, because that one would have made A, C true as well. So if we're just looking where A is true, B is true, and C is false, we just take this part here because this is falling right outside of the purple border. So C is false here. And A falls within the orange part of the circle here. So that's good. And it falls within the green part here, but it's falling outside of C. So C is false, but A is true here. It falls within here. A is true and B is true. So that's what this is representing basically. So this is just A being true and B being true, but C not being true. That's what this represents here. And this is 0, so that doesn't happen. But this is just based on the same example as before, but you would have like hopefully some non-zero values there. But I just want to show you kind of step by step by step. So whatever the values are from your joint probability distribution, you can always map them to a Venn diagram like this. So I just hope that this was helpful for you guys, just to see how you go from a joint probability distribution all the way to a Venn diagram representation of them, because if you're a visual learner like me, that could be helpful for you to just visualize what these probabilities mean, how to interpret these outcomes. And the sample space of all these outcomes is usually given by omega, which is the sample space in probability. I hope that this is helpful for you guys. So again, guys, just to recap from this video, you would see how we can go from a joint probability distribution of any, for these are three random variables. So hopefully you can do this for the simpler, two random variables, which would just be a simple Venn diagram. You can just have the simple Venn diagram of outcomes of, these outcomes. I can't even draw for my life, Yangshi. You might even draw better than me. But you see sort of how you can go from here. Three random variables, so 8 total outcomes, 2 times 2 times 2. So any of those probabilities, how you can just map them to the Venn diagram of representation. So this one, this orange, is just only A, so only A is true. So A is true, and B is false, and C is false here. And then this point 2 here, it corresponds to this part where A, B, and C are all true as well. So, Yangshi, do you think you understand the probability of how to do this? Do you think so? He might need to watch it on YouTube. He says, nah, he doesn't quite get it. I hope you do. And if you found this helpful, please subscribe to my channel as well. So Yangshi is hoping that you subscribe. It'll make him happy and me happy too. So this is just in a sequence of probability videos and biostatistics, but I just really hope that this helps you guys. Again, we're just visualizing your results. So basically here, if A is false and B is false and C is true, then this is 0. So what this is saying is that this is just basically saying C only, which is what this part is. So this part is just the 0 here. The 0, that's what this is saying. This is just C only. And then, if A is false, if B is true, and C is true, this is just the intersection of B and C only. So that is this point 2 here, basically. Oh, that's this point 3. Sorry, the point 3 that is given by the intersection of B and C here. But there's no A that's allowed because A is false. So we only look at this part here, this point 3. That's what this is representing here. Then what this part is that if A is true, B is false, and C is true, this is similarly the intersection between A and C, but it's not including B. So this is the intersection between A and C, which is point 2. So this thing here is basically, this point 2 is just this part here, this point 2. From here, this point 2 is basically A intersect with C, but it does not include B. So this is the part of A and C, but B is not included here. If B was included, it would have been this red part here, which actually is A is true, B is true, and C is true. So this part of the circle falls within all 3 circles. And this is this point 2 here. This point 2 is what this part here is. And similarly, if all 3 are false, That is what's given by this point 3 here actually. Um, this point 3 is basically everything outside of this like figure is point 3. So that's when all three of them are false. And similarly, if A is false and B is true and C is false, that's just the probability of B being true, which is just 0. And then the rest are also 0. So if A is true and B is false and C is false, that is just A being only A being true, which is what this orange thing is showing. This orange thing is only A. And lastly, this is just A and B being true but C being false. So that is given by this part here, because this part here, it does not fall within C. So this part right here of 0 is actually this part here. The 0 is the 0 here. So that's sort of how you can take the probability, the joint probability table and represent it in a Venn diagram, and then you can interpret it that way. Thank you so much for watching this video. Thank you.